Rock formations and earth forces. That's our topic for today. So we've learned how to make a rock over thousands of years, and we've learned that the crust of the earth tells us the history, right? And we learned that the deeper down you go in a sedimentary rock, the older it is through the law of superposition. Well, now we're going to put all that together and see how some things don't quite fit into those molds, okay? And understand how things change on Earth. Because if you notice, you look outside and everything's a little different. The landforms that you see here are not the same as that you see across the river. And the landforms you see across the river aren't the same that you see on the coast. And we're gonna understand why why the earth looks the way it does. So sometimes rock layers are disturbed by different earth forces. This means that the pattern we typically see in a rock, the layers being further down the older and the newer to the surface being the younger, sometimes they get mixed up. Remember, we talked about how humans can kind of do that the other day, but Earth does it to itself. And so think about that. What are some of the things that the Earth does to itself that causes those layers to get mixed up? So there are really about three things that the earth does that totally causes the law of superposition to get mixed up. And that would be things such as earthquakes, rivers, and erosion. Okay. Those three things can disturb the law of superposition. So I circled this line right here so you can see patterns in rock formations can show where earthquakes occur. Earthquakes are the shaking caused by the movement under Earth's surface, and they occur and layers no longer align. So the rock layers impacted by an earthquake often show distinct change at the fault line where the earthquake occurs. So we're going to understand that all, okay? Let's break all that. We're going to break that all down in just a moment when we talk about plates, okay? Another way is rivers. So rivers are strong forces that impact rock. Often rivers cut through rock, leaving rock layers exposed. Rock layers also deposit new sediment in the middle of old rock layers. Okay, great example of this is right now going on the Mississippi River. When you cross over the JB Bridge, you're going to see huge sandbars all over. That's sediment. We haven't had much rain, so the sediment is showing remarkably right now. So if you get a chance to go over to South County, look out your window as you drive past, because there's some fantastic examples of sandbars right now on our river. Erosion. So erosion is when different forces such as rain, wind, flowing water, and living animals can erode or wear down rocks. This erosion wears down the rocks and creates new patterns in the rock layers. So this is where the rocks break off, all right? We're going to be talking about weathering and erosion coming up here very soon. But erosion, just remember, they are forces that break apart and move rock, okay? So they move the rock. And we're going to explain this a lot more in detail coming up, okay? So often the causes of Earth's forces are disruption in Earth rock patterns is the tectonic plates and the movement of the plates that make up the crust. Okay, so remember we said the crust was not solid. It is pieces of rock that are floating on top of the mantle, okay? The mantle is liquid rock. So we have the core, the mantle, the crust, okay? The crust has all the pieces of evidence of what Earth history was about, but they're floating on top of this thing called the mantle. Now, as those pieces float, they interact and they cause disruptions. This is an example this is what the plates look like. And let me see if I can move some of these things. Actually, let me erase this one. I drew this in earlier just to be able to see it myself a little bit better. But this is just a quick little drawing of here is North America, South America, Europe, and there's Asia, Africa, Antarctica, and Australia. You know that song you learned a long time ago? Well, these are the continents. And if you notice, there's a lot of extra lines in there. These are the plates. They're broken up just like a puzzle piece. If you notice, this green dot I put here is where than where North America is. And we are on a continental plate. Okay. There's oceanic and continental. We're going to be talking about those in big time detail coming up here. But if you notice, they all are floating around on this thing called the mantle. We can't see the mantle, but these plates are miles deep. So, but these plates are constantly floating and they interact. So, sometimes the plates fit so close together that when they interact, sometimes they bump and sometimes they rub against each other and sometimes they are pulling apart and sometimes they're pushing together. These enormous plates that are all floating on top of the mantle. So these forces are causing disruption in the rock layers. So here's an example. Here is a cross section of the under Earth's surface. And these layers of rock that make up the crust are floating on top of the thick mantle of liquid rock. So that's what they are. So this one is not disturbed. If you look over here, this one is sure disturbed, right? So earthquakes are one example of Earth's forces that are caused by the tectonic plates moving. So earthquakes occur when plates interact, typically when they push together or they slide past one another. Try that with your fist. Push together or slide past one another, okay? They can disturb the rock. Earthquakes often leave visible marks on the Earth's surface, but they especially leave visible marks on the rock layers, okay? So remember, this was just for me doing this. Now, can you imagine if there was a plate in here going back and forth, back and forth, back and forth, back and forth? Oh, look what happened to the law of superposition there. Look at that. And that's going back and forth with the earthquake. Those layers will never be the same. So tectonic plates can also cause rock layers to bend and to fold. And this is a good example. Is every part of the United States flat? No. Do we have hills? Yeah. We have all sorts of landforms, and a lot of them are caused because of the tectonic plates below the surface, in the crust, but below what we see. And so we're going to understand that even more, okay? So when Earth forces disturb typical rock formations, it can be trickier to understand what has happened to Earth's history. And bingo, look at this. There's no more straight lines, are there? So what do they have to use to be able to guess what life was like and what the history was? Well, they use fossil evidence, right? And so when they're looking at this, remember we talked about similar fossils means similar time. All right. So if there's different fossils, it means different times. And so they have to look and compare rocks. But look at how mixed up this is. So they can see, though, if a rock that is found down here matches a rock that's found up here, it was probably caused by a disturbance that mixed up those layers. Because over time, animals have changed. So if the fossils have changed, we know if the fossils are different, we know that it's a different time, right? If it's similar fossils, it's a similar time. So let's answer some of these questions, and then we'll get ready for tomorrow's lesson. So if the Earth forces have impacted rock in an area, will younger rocks always be on top and the older ones always on the bottom? What do you think? I bet this answers the question. Are they always going to be in line? No, they're not. That's right. So Earth forces can cause rock layers to what? Disappear, fold up, unalign, or swap? What do you think about that one? Are some of these layers gone? Yeah, they're kind of gone. You can't even see them anymore. Are they kind of folded up on top of each other? Absolutely. Are they unaligned now? Have some of them swapped spots? They sure have. They can be totally mixed up, totally disturbed, right? So all of those are correct. So this case, it looks like this could potentially be a what? What do you think that was? Ooh, could it be a river? And remember, we just talked about this at the JB Bridge. Look for this, where it washes away. This is called sediment, remember? So I want you to look at that when you go across the JB Bridge next time. So let's see if we can answer this question. The crust is a solid layer on the outside of Earth. Is that true? Is it a solid? No, it's not. It's floating. It's floating on what is that again? The crust is floating on the mantle. That's right. And it's all those pieces, all those plates, all floating tight together, but disrupting each other. Sometimes they're hitting each other. Sometimes they're slaying past each other. Sometimes they're going to be going like this. We're going to talk about that. Sometimes they're going to be pulling apart. They're going to be doing all sorts of disruptions. It's like a brother and sister who can't always get along. Sometimes they're like this. Sometimes they slide past each other in the hallway, right? Sometimes they don't have anything to do with each other and they start pulling apart. Just think of it that way. So, crust is broken into pieces called what? What are those things called again? They're broken into plates. They're broken into plates. They're broken into plates. They're broken into plates. So the crust is broken into plates that float on the mantle. And then we have the core, right? So you have the plates that are the crust, you have the mantle, and then the core. So tectonic plates, let's see, do they never move? Do they? No, that's not the case. They move all the time. Interact with their boundaries. Oh yeah, earthquakes. We just talked about that. Can cause earthquakes. Bam, 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 bam. Earthquakes are very thin. Plates are miles deep. That's why we can't see them. All we see is the result on the surface. So that's why we're studying them, to know what's happening below the surface. And then tomorrow we'll dive even more into tectonic plates. Science rocks.